Okay, so we're on question 11, and question 11.1 says two events A and B are such that the probability of A is equal to 0.4, probability of A or B is equal to 0.52, and then A and B are mutually exclusive. And now we have to calculate the probability of B. Okay, so to find this, we need to understand what they mean by the probability of, or A and B are mutually exclusive. So if things are mutually exclusive, okay, you can see it like this. I usually just say this to my students so that they'll remember. The events have mutually decided to exclude each other. Okay, so mutually exclusive events are events that do not intersect. Okay, so that would be event A and B. So because they are mutually exclusive, as you can see, they do not intersect. So they don't have an intersection. And I want you to note that when they say events are mutually exclusive, that's really what they're trying to point out. They're trying to tell you that they don't intersect. So what does that actually mean in probability? If things do not intersect, what it means is the probability of, so we're talking about A and B here. So the probability of A and B, because they don't intersect, okay, there is no probability of A and B. There is no event where these two events are happening together. So that would be equal to 0. So we can use this now to actually find the value of the probability of B. So we'll simply use what they told us here. They told us the probability of A or B. Now that has a formula. The formula for that is the probability of A or B is equal to the probability of A plus the probability of B, and then you usually say minus the intersection, right? Minus probability of A and B. But we already know that's 0, so we don't even have to include it because it's like minus 0. So let's fill in what we have and you'll see we'll find the probability of B. So probability of A or B, they told us that that was 0.52. And this is equal to the probability of A, which is 0.4, plus the probability of B, which is what we are looking for. And now you see that we have formed an equation. We can leave the probability of B on one side and say 0.52 and take the 0.4 over. This is kind of like 0.40. So it's like 52 minus 40, which will give you 0.12. And that would be your probability of B. Okay, moving on to the next question. The next question, 11.2, says, the items that a learner bought at the tuck shop were recorded over a period of time. The probabilities of the learner buying a sandwich, a chocolate, and a juice, so those are represented by those letters, are shown in the Venn diagram below. So this is the Venn diagram that we have, and everything is in decimals. That is not a bad thing, okay? Decimals are already in they're already in probabilities, okay? So because they're already in probabilities, you don't have to think about, oh, what do I have to put it over? It's already in a probability format. So we have 11.2.1. What is the probability that the learner will buy a sandwich? Okay, so if you guys want to learn more about Venn diagrams and you want to do better with Venn diagrams, I'm going to recommend these two videos that I'm showing you now on screen for you to go ahead and practice with. So you can go ahead and check that video out. I hope it really helps. So they want the probability that the learner will buy a sandwich. So you see that we have the different circles, the chocolate, juice, and sandwich. You see, they did not say the learner is going to buy a sandwich and not a chocolate and not a juice. They just said a sandwich. So regardless of whether the learner is going to buy chocolate or juice, as long as they bought a sandwich, we're going to take that. So that would be, when you're looking for a sandwich, it would be the entire circle of sandwich. Because every probability here includes whether the learner bought a sandwich, okay? Here the learner bought a sandwich and a chocolate, but they bought a sandwich, okay? So that's what we're going to take. We're going to add all of those numbers up, and that should give us our answer. Okay, so this is what we have. The probability that the learner bought a sandwich would be 0.16. And that will be our answer for that question. Okay, moving on to the next question. Okay, 11.2.2 says, calculate the probability that the learner will buy at least 2 of the 3 items. So calculate the probability the learner will buy at least 2 of these items. I also explained this in that video of Venn diagrams in the first video. So let's actually look at it like this. We want to see the probability that the learner buys at least 2 items out of all the items that we have here. Just go to each probability and ask yourself, in that part, in that 0.04, that is just the chance that the learner will buy a chocolate, right? How many items did the learner buy here? They bought only one. They may not have bought one chocolate, okay? But they bought one item type, which is the chocolate. Because this circle, right, in the circle, as you can see, it is not inside. It is not included in the sandwich. So it's not like this situation where the child is buying a chocolate and a sandwich. This is just a chocolate on its own. So it means here the child bought one item. We can't take that. They said at least 2 items. So also just note that at least means at lowest. So it means that the lowest amount of items that this child must buy should be 2 items. So as long as it is 2 items and more, then we're going to take that. Okay, so we can look at each of it and ask, so how many did they buy here? 1 item, only a chocolate. Okay, how many items did a child buy here? That would be 2 items because the child bought a chocolate and a sandwich. You see that is part of the intersection of chocolate and sandwich. Okay, so that's going to be included in our calculation. What about this one? How many items did a child buy here? That's 1 item because you see that that's only sandwich. There's no intersection here. They bought 1 item. What about here? That's 2 items. That's intersection of chocolate and juice. Okay, so that will be 2 items. And here, how many items is that here? Well, as you can see, that's the middle. That's the intersection of chocolate, sandwich, and juice. So that's 3 items. This child must buy 2 or more because they said at least 2 items, meaning at lowest 2 items. So 2 or more items is fine. So we include that as well. And lastly, this one, because this is juice and sandwich. Okay, so these would be the answers that you would add up. That's what you're going to add up to find out what is the probability really that the learner is going to buy at least 2 items. And when we add these all up together, we get 0.01, which is really a 0.10. But when the calculator simplifies it, it's 0.1. Okay, so 0.1 actually. Okay, so that's what we get there. And that is that answer. Moving on to the next question. Then we're on the last question in this Venn diagram, and 11.2.3 says, calculate the probability that the learner would not buy any of the 3 items. So the only items we have are the 3 items. So if we're finding the probability that the learner will not buy any of the 3 items, we will be finding the probability that is outside the circles. Okay, because this would be people who didn't buy any of these. So how do we actually find them? Well, you have to think about it like this. Each of these probabilities, when you add them up together, they will give you the probabilities of all the items that were bought, right? Of all the 3 items. So if you want to find the probability that the learner did not buy any of these items, you're going to have to think about what everything, including the one outside, right, is going to give you. What everything is going to give. What's the probability of all the items and even the probability that the learner is not going to buy any of the items? When you add all of these up together, because they're already in decimals, it means they're already being written as a probability, okay? The probability of every single thing added up together is 100%. As a decimal, you can say that is 1. So we're going to have to say 1 minus the probability that the learner is going to buy every item that they bought. And that will be minus everything we have in all the circles. So take 1 minus everything because it's in decimals, and it's going to give us the probability of the learner not buying any of the items. So that is going to look like this. Also, the notation doesn't really matter that much, but I'm really just saying it's the probability of not A or not B or not C. If you watch the Venn diagram video, you understand what the word or means better. In a nutshell, really just means to add. Okay, so when we calculate this, it's 1 minus the addition of everything in the circle. So this would be equal to, when we finally calculate that, we get 0.57. So 0.57, which is really a 57% chance. Okay, so it's really higher than every other item that he has bought. Okay, so that is it for the Venn diagram question, and then we move on to 11.3. Okay, so now we're on question 11.3, and it says 7 guitar players, each with a different name, participate in a concert. In how many different ways can the names of the guitar players be listed one below the other in the program? Okay, well, they said there were 7 guitar players, okay, with different names. So how many different, well, that doesn't really apply to this, but how many different ways can the names be listed one below the other in the program? So if we're looking at it like the list, there's 7 places because there's 7 guitar players, right? So that's 4, 5, 6, and 7. So since there's 7 guitar players, when you're thinking about where the first guitar player is going to be seated, that guitar player has 7 choices, okay, to sit at. You can sit here or here or here or here or here or here, right? So that person has 7 choices. Then after that person is seated, because they say one below the other, which is probably just their hint for no repetition. So after that one is seated, the next guitar player has how many places that they can be positioned in? That's going to be 6 places left because the first one is seated. And then the third one will have 5 places, and 4 and 3 and 2 and 1. And to find the amount of ways, we would multiply all of these. So as you can see, that is actually 7 factorial. And if you find 7 factorial on your calculator, I think it's like 50, 40, let me see. So 7 factorial, yes, it is 5,040 ways. Okay, so there we go. So that's the first question. Moving on to the next question. Then 11.3.2 says, after the performance, the guitar players wait backstage. There's a bench with only room for 4 to sit on. Okay, so the 7 guitar players are waiting backstage. And then there's this room that has a bench for only 4 people to sit on. Okay, so the question is, what will be the probability that the 4 guitar players will be sitting in alphabetical order from left to right? Okay, so let's look at this. The guitar players, there's 7 of them, right? They want the probability that 4 of them are going to be seated in alphabetical order. Well, if they're in alphabetical order, there can only be one way for that to actually happen, because you're either in alphabetical order or you're not in alphabetical order. Okay, just knowing that, because they did mention that their names, they have different names, right? So as long as there's no guitar players with the same names, then if they're seated in alphabetical order, then of course we should have only one way that can happen. Okay, since it's the probability, we know that it is 1, right? But it's over something. They gave us a scenario here. So the scenario is that we still have the 7 guitar players waiting backstage, but then there's this bench with only room for 4 to sit on. So this would be what it's out of, because this is what we're comparing it to, really. They're saying now that these 7 guitar players are sitting backstage, there is a bench with only 4 places for them to sit in. Now, from that scenario, what is the probability that they will be seated in alphabetical order? So we're going to have to find out how many ways can these 4 guitar players be sitting on that bench. Well, let's remember that there are 7 guitar players originally. Okay, so let's just give them names. Instead of giving them names, let's actually just name them in letters. The reason why is because they should be in alphabetical order, right? So I think this would be easier if we use letters. So if we go, let's say the first one is A, B, C, D, E, F, and G, right? So these are the 7. Now there are only 4 places to sit at. Let's think about it like this. So let's think about the first place. What are the choices that we have for the first place? Well, the choices that we have is that we have 7 different guitar players. Now, any one of them could be seated in this first place. So it means that there are literally 7 different choices of guitar players that could be seated in this first place. So that's 7 choices that we have there. Then, after that first person is seated, how many choices do we have? Like, who could be seated here? Since the first one is already seated, you'd only have 6 choices of guitar players who could sit here. So it's like, let's say we said A was seated in that first place. Then it means that there are only 6 more guitar players, right, that could take this second position. Then after that one is seated, let's say it was B, right? There would only be 5 more positions and then 4 more positions, okay? So that's how we're going to get the total amount of ways that they can be seated on the bench, right? Just on that bench. So that would be, we'd have to multiply that, of course. But then they say, what is the probability that the 4 guitar players will be sitting in alphabetical order from left to right? The only way they can sit in alphabetical order is one way, because even if it was just B and D and let's say E and G, if I decide to move G here, they're not in alphabetical order. Okay, so regardless of who is sitting, there's only one way they can be in alphabetical order. Okay, so that means to find the probability, we will just say 1 over the scenario they gave us, okay, which is just all of this. If we multiply that, so let's see what that gives us. 7 times 6 times 5 times 4, it is 840. So the probability is 1 over 840. Okay, so that's the answer there. And then moving on to the next question. Okay, so we are on the last question, 11.3.3, and it says, during the performance, the 7 guitar players sit in a line on stage. 4 guitar players are female. Okay, so let's highlight that. 4 guitar players are female and 3 are male. Then they say, in how many different ways can they be seated if the males may not sit next to each other? Okay, so the males may not sit next to each other. Honestly speaking, when I'm thinking about this, because they told us that 4 are female and then 3 are male. When they say in how many different ways can they be seated if the males may not sit next to each other, I'm kind of thinking, do they mean like the 3 males specifically must not be next to each other like that? Or do they mean like we must just never have any males next to each other? Okay, let me just think about that. Okay, I'm just going to go with this. The thing is, they're saying if the males may not sit next to each other, okay? So since they cannot sit next to each other, I'm going to see it as no males must be sitting next to each other. Okay, not necessarily just the 3 males sitting next to each other. Okay, so even if we have 2 males sitting next to each other, I mean, that would be a situation where you have males sitting next to each other. So since they said no males must be sitting next to each other, then we should also not have situations like this. Okay, so this seems like, in fact, it looks a lot similar to last year's November paper. You'd have noticed that in November 2023, the paper 1, the probability part, which I did post the video on, that last question was also one of those types where if you think about it as a picture, you'd be able to sort of think your way through that question. Okay, so you had to kind of like visualize what was going on there. This one also seems like one of those, so there's going to be a lot of writing. Let's just think this through. So we need to put this scenario where no males must be seated next to each other. Okay, fine. So let's think about the places we need to put the males so that they're not next to each other. How about we put down the females first? So we're going to put it as female, 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 and female. Okay, so we know there are 3 males. How should we place the males so that there are no males next to each other? The only places to place them, I see 5 places that we could put them. We could put them here. You could put a male there. You can put them here, 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 and here. Okay, so if they're in between the females like that, in any of these 5 places, then they're not going to be, next to another male. Okay, so the males can be seated in these 5 places. But remember that there are only 3 males. So we'd have to kind of try to think about the arrangements that can be made if the males are seated in any of these 5 places. Okay, so the first one, okay, and I'm also just going to copy this just so that I can constantly just paste it down and then think about the placement of the males. So when we're looking at this, the first type of placement I can think of is where I put a male here, a male here, and a male here, right? So there. Then secondly, the second way the males can be placed would be maybe you put a male here, a male in the second place, and then we can move that male there. And then in the third one, we'll move that male there. Okay, so male here, then we put this male over here. Then of course in the third placement, we can have a male here, a male here, and then we're going to move that male right to the end. Okay, so that's not all the types of placement. I guess we have to categorize this. We can actually call this, let's actually focus on this being the placements where we make sure that the male is first. We have a male in front of the female, right? So I'm going to call that male first. Okay, then we'll also deal with the situations where the male is second, okay, instead of first. So what other placements can we have? We can also place it like this. I can also see other ways that the males can still be first. So a male is first. Then instead of putting this male second, I can put the male third and then another male. Then in the second one after this, we can have still male here, male in the third place, and then this male can be there, okay? So like male, male, and male, like that. Okay, we could have that as well. And then there's one more way we can put this. So how about we put, again, the male first. I'm looking at all the situations where the male is first, right? So a male here, and then, so you see that here we were working with the male being first and then a male being second. You know what I mean by second, like in the third position, right? So it's the second male here. And then we also worked with a male being first and then a male being third. Then we can also work with a male being first and then a male being fourth. That makes sense. And male. But you see that after this, if you try to, try to push this male to that side. So if you try to push that male, so if you had like a male first, then you had male, then you see it's not going to work out here anymore because now the males are next to each other. So that would be the end of when we try putting a male first. Okay, so how many? That's 1, 2, 3, 4, 5, 6 arrangements so long. Okay. Now remember, there's still 5 places. There's 5 places that the males can stand. So we can actually now try where the male is just second. Okay, so we keep this aside and then we try male second. Okay, so I couldn't really move that nicely, so I just leave it in the middle there. So let's try when the male is second. Okay, so in this placement, when we have our females, we're going to put the male second. Okay, so if a male is second, we could have a placement like male, male, and male. Okay. Then, again, if the male is second, we can try like male, and then let's keep that here, and then move that one to the end, male. And then, again, this is very tedious, but I feel like it's the only way that personally I can visualize what's going on. So the other one that we can have, well, we can't push this male any further. So now we can try still leaving the male second, but instead the second male is not going to be here anymore. Let's put the second male here. So male like that and male, right? And then you see after this, you can't really move this male here because then he's going to be next to another male. So that would be the only placements for the male being second. Okay, let's try placements where the male is third. So male third. So male third. Let's try that. Okay, we're going to have as our females again. And let's try putting the male in the third position. You see what I mean by the third position, the third male position that we have, since we have 5 different male positions. So the third one, that will be male, male, male. I don't think you can go further than that though, because like male, 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 that's it. You can't move that male there, because he'll be next to the other male. So this would be all the possible ways that they can stand and the males will not be next to each other. These are all the possible ways. How many arrangements is that in total? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 arrangements, 10 ways that can, it's not 10 ways in total. It's 10 arrangements, 10 picture arrangements. That's what I'll just call it. Okay. So now that we have that, we also have to consider what's going on in each arrangement. Remember that these females are not the same people and the males are not the same people either. So it means that this female particularly doesn't have to be seated here. She could be here or here or here, right? Because of that, we also have to now consider what's going to happen with that, the kind of pattern it's going to create. So let me just move this here. So looking at the pattern that is being formed, we're really just, it's like you're grouping the females. Just looking at it in this picture, it's like you're grouping the females, but in a pattern way. You're saying that a female must be in the second position, in the fourth position, in the sixth, and in the seventh position. This is a group. So those females, because they're not the same people, they're different people. This female doesn't have to be here. She could be here, here, or here, right? And so when she's seated, the other female doesn't necessarily have to be in this position. She could be here, here, or here. So she has 3 places. And then this one has 2 places. And then she will have 1 more place. Because of that, the females make a group of 4 factorial, right? Then we can also do the same for the males. So we'll say multiply by, and let's look at the males. The males as well, they've also been put in a pattern, in a group, okay, group-like pattern. So a male must be first, a male must be third, and a male must be fifth. Because of that, we can also go ahead and say that that's going to be 3 factorial. For the same reason, this male doesn't necessarily have to be in this first place. He could be in the 3rd place or the 5th place. And after he's seated, the second male doesn't have to be in this 3rd place. He can be in this 3rd place or the 5th place. And then the last male would only have that place. So that's why it's 3 factorial again. So that's what that group creates. And then if you do the same for every other group, you see that it creates the same thing. Because all we're doing is we're saying that the females have to be in these particular positions and the males have to be in those particular positions. So that will be also 4 factorial times 3 factorial. And we'll keep on having the same thing, 4 factorial times 3 factorial. But how many times are we going to have this rule? See, same thing, 4 factorial, the 3 males again, 3 factorial. We're just grouping them in that way. So that's the thing about the counting principles. The number, the answer that you get is not going to show you how they're seated. It's just going to count it. So when we actually find in it, when we represent it as a picture, then we can actually see how they're seated. Okay, so because of that, what I'm going to say is, since I know that there are 10 pictures or 10 categories that we can have like that, I'm saying it's 10 of that multiplied by each of them are going to all be 4 factorial times 3 factorial because of the type of patterns they create throughout. So 10 multiplied by 4 factorial times 3 factorial. And that's going to be our answer. So let's go ahead and calculate that. Okay, and the answer that I get there is 1,440 ways that they can be seated. Okay, so I think it was a lot similar to the November papers one as well, because they also had something like that where you kind of had to represent it and see the different patterns that they create. Okay, so that is it for this paper. The paper is a total of 150 marks. All the best to all the matrics that are going to still write their June exams. And I'm going to be working on paper 2. So see you guys in the future videos.